Nope, no. Okay, here we go. Carrying on. See if I can try and go a little bit faster because, of course, you can always rewind or forward these videos. Okay, next up. Which of the following, okay, I don't know, which of the following calculator keystroke sequences would you give the solution? Would give the solution to the following. So, yeah, on a question like this, we have to think of order of operations and just understand a couple of things. So, on one hand, I have 33 plus 9 on the top, all divided by 6 times 5 minus 2. So order of operations, we say bed mass, right? We have to think of this. So we've got, um, we don't have, so yes, we're going to do, let's see, brackets first. And if we're evaluating this by hand, we would do this first. But we've also got this big line here. Okay. This big line is saying this whole thing divided by this whole thing. So when we do that, we can kind of think of it like this too. We can think, if I want to keep this top part together, I'm saying this, I have to write this like this, 33 plus 9 in brackets. I could write that as divided by all that stuff we had on the bottom there. Try to squeeze that in there, 6 times 5 minus 2. Okay, so when I have something like x plus 2 divided by, um, I don't know, I'll just say 2x minus 2, we're saying this whole thing is divided by whatever this is. Okay, so another way to write it again would be with a division sign, right? So like this, and then 2x minus 2. Okay, so if we think about that, that's going to help us in kind of using this on a calculator, okay? I'm just going to erase this part though, so we don't get confused. What if I do this? We're going to have, let's see, 33 plus 9. If I put a, let's try this one. If I put a bracket, well, it kind of looks like what we did here, right? Like that. 33 plus 9 plus, yeah, 9, put a bracket. So that's going to make sure we're kind of keeping this whole thing together. Then we're going to divide. But if we divide by 6, that would seem like we're just taking 33 plus 9 and dividing by 6, and then multiplying that whole number, whatever that is, by 5 minus 2, and that's not what we're doing. So we need to remember that whatever was on the bottom here, when I say we're dividing by this whole thing, we got to put that in brackets, right? Like we did over here. So there should be another set of brackets. So this isn't looking good to me. And these don't have brackets to begin with, so those don't look good to me. Let's check D. So I've got bracket around the 33 plus 9 bracket divided by bracket here. And let's look at a bracket over here. Okay, so I'm punching in bracket 6 times bracket here, 5 minus 2 bracket, because we want to make sure that the calculator, because if you don't tell the calculator, it's going to just add these without parentheses. The parentheses are important because we don't really have a way in a calculator to write stuff like this. We have to write it in this kind of left to right, this sort of left to right way. So we would be here now 6 times parentheses 5 minus 2 parentheses equals. So this is going to be the right answer. Now the calculator knows essentially we're doing this first, right? Then we're doing this, and then we're doing this, and then we're taking those two pieces and dividing them together. Okay, dividing, sorry, one by the other. All right, so hopefully that helps. I don't know if we're going to have a question like that, but if we do, well, now you know. All right, next. Kaylee earns $15 an hour and her monthly expenses are $1,150. Okay, So she earns $15. That's how much she makes. That's good. She earns $15 per hour. And bad expenses. Expenses are $1,150. That's how much how much she has to pay every month. So which of the following inequalities can be used to determine the number of hours, T, that Kaylee must work in 1 month to save at least $200? Okay, what of the following inequalities can be used to determine the number of hours T that Kaylee must work in a month to save at least $200? Okay, let's just do this for a second. Let's just think about it as an equation first. Okay, we're probably more used to doing that, and then we can kind of worry about which sign to choose after. Okay. So let's think about it. How many hours would she have to work in order to save $200? Exactly $200. So to save $200, should have to take the money that she makes and then subtract her expenses, and that would give her, she would be left over with $200, right? So the money she makes is $15 an hour, but we have to multiply that by the number of hours, right? So let's say H for hours. So 15 times H, which is some number of hours. Then we're going to subtract her expenses, which we said were 1,150. And that would give us $200. Okay, so let's just solve this equation first, okay? So we're gonna add 1,150 over to this side, right? So kind of like we did a second ago, you could either write this here plus 1150 on each side, or we can just kind of know we're moving it over to the other side and we change the sign, okay? So now we've got 15H equals 200 plus 1,150, which is equal to 1,350, okay? So we have 15H is equal to 1,350. Now if we divide, so again, I could write divide by 15, divide by 15, cancel this, then H is equal to 1,350 divided by 15. Okay, or I can just think that, yes, this here is multiplication. When I move to get it over to the other side, I'm doing the opposite, I'm dividing, right? So H is equal to 1,350 divided by 15, which is, calculator here, 1,350 divided by 15. So that means she would have to work 90 hours. So she works 90 hours, she's going to have $1,350. And then after expenses, she would have $200 left. So, oh, they didn't actually ask us the number of hours. What am I doing? Which of the following inequality? Oh, okay. Sorry, it's late. I'm tired. Okay. Well, she would have to work 90 hours, but we set up the equation. Okay, 15. I said H. They use T. Time. Okay, we'll say time minus 1150. We know that it's 15 hours times the time. Subtract her expenses to give $200. Now, this is where we have to think. So we didn't need to do all this work. So don't be like me. Pay attention to what your answers for a second. That can give you a hint that you're not actually trying to solve for H. And we're just trying to pick the right equation. So we know, and they even give us this here. They're giving us hints, so helps us, right? You've got 15 times T. Okay, we know that we're either going to add that $1,150. We're going to subtract it. Well, it's an expense, right? So we have to subtract it. So we know our answer is one of those two. So if she's going to save at least $200, so this amount here, if if what she earns minus her expenses is less than or equal to $200, that's going to say she's never going to get more than $200 because what she's going to earn is going to be less than or equal to $200. But they want her to save at least $200. That means they want her to save $200 or more. So the right answer would be C. So let's think about that. Money she makes minus her expenses needs to be greater than 200 or equal to. Okay. Now, if they give you the choice of 15t minus 1150 is greater than 200, that wouldn't be the right, that wouldn't match with at least, because greater, they would if it was just a greater than sign, that would be something more like she has to save more than $200 because we're saying this has to be bigger than. But when we put that equal to sign, it's saying it can be that. It's okay if it's $200 or more. So we're saying at least $200. So at least means equal to 200 or more than 200. Okay. All right. So yeah, don't worry about that. Okay, and we'll carry on. So I wish I could pause these recordings and think a minute first, but I'm doing my best with the time I've got right now. So hopefully it still makes sense to you. Again, let me know if you need to ask some questions. We'll go over it. Okay, next question. It says the tail rotor blade of a helicopter shown below rotates 4 times for every 1 main rotator blade rotation. So here we have this main rotator blade, and here's the tail rotor blade. It says that the tail rotor blade rotates 4 times for every 1 rotation of the main blade. So if this one flips around 4 times, this one only turns once. So this one's turning much faster, right? 4 times faster than this one, which is turning slower, okay, compared to the one at the back. So the question is, how many times will the helicopter's main rotor blade, the big one, main rotor blade, rotate if its tail rotor blade rotates 600,000 times? Okay, so if this one rotates, so the tail rotor rotates 600,000 times, which one rotates more? The rotor blade or the main blade? The main blade rotates less, the rotor blade rotates more, right? 4 times more. So if I have 600, oh, did I say 600,000? 600 million. We know that my main rotor blade should be less, right? Because they said the tail rotor blade rotates this many times, and the tail rotor blade is the one that rotates more. So think of it like a scale factor kind of question, right? And in this case, I'm just going to think I'm either multiplying or dividing by 4. Okay, since this is my tail rotor that turns 600 million times, I know that my main rotor blade is going to have to be less. So if it's going to be less, I'm going to divide by that amount. Okay, I'm going to divide by 4. So let's take that 600 million divided by 4, and I get 150, I think that said million. Yeah, that makes sense. Okay, 150 million. So now we just have to represent this in a power of 10, right? So here I've got some options. Well, we already know it's 150,000. There's my 1.5. So it's got to be one of these two. So is it 1.5 times 10 to the 8th or 1.5 times 10 to the 9? I'm going to show you an easy way to figure that out. We're going to put this here. Let's pretend there's a decimal there. How many how many places would I have to move that? How many factors of 10 would I have to multiply 1.5 by to get 150,000. I would have to move this 1, 2, 3, 4, 5, 6, 7, 8, right? So my answer is going to be A, 1.5 times 10 to the 8, right? So think about it this way. If I had 1.5, what is 10 to the 8? 10 to the 8 is 8 zeros. There's actually 100 million. So if I multiplied that by 10 to the 8, we know like when we multiply by something by like a 10 or 100, when there's zeros, we move our decimal place by that same number of zeros, right? So if I have 2, 3, 4, 5, 6, 7, 8 zeros, that's what 10 to the 8 is, and I multiply this by something with 8 zeros, it's going to move my decimal place 8 times, right? So it's going to give me, like we saw above, okay? All right. Next question. We have some triangles, and it's asking us which figure does not prove congruency. Yeah, we went over this question in class. We talked about in class similar triangles. We know that similar triangles, if we have all the same angles, they're similar. And remember, similar means that the angles are the same and they're proportionate, but they could be different sizes, right? Those are similar triangles. A congruent triangle is like a special case of a similar triangle where it's actually the angles are the same and the sides are the same. So it's basically a congruent triangle is a triangle that's the exact same size. Okay, so which one does not prove congruency? So if all of my sides are the same, I know these triangles have to be the exact same size. There's no way around that. So we can see here, we have the same sides, same sizes, same lengths all the way around. So that one is congruent. Meaning it's the exact same size. These triangles here, we've got two sides that are the same, here and here, and we have an angle in the middle that's the same. They're both 90 degrees. This is also congruent because think about it. If we have two sides of a triangle and they're separated at the same angle, they're both the same length, separated at the same angle, there's only one side length that would fit in here. They would have to be the same size. So these are also going to be the same. Now again, we have an angle that's the same and two angles that are the same with a side length in between them that's the same. So think about it this way. If I have two sticks and they're the exact same length, and then I draw a line off at the same angle, and then I draw another line off at the same angle, they're going to cross at the same point every time because they're shooting off at the same angle. So these sides are also going to end up being the same side. So these are also congruent. The one that does not prove congruency is the one that only tells us that all the angles are the same. This angle is the same as this angle is the same as that, and this one is the same as that one. So here we could have a triangle with the same angles, but these could be two different sizes. So these are not necessarily congruent. They could be, but they could also be similar triangle that's not congruent. They're different sizes. So angles alone will not tell us that they're the same triangle. Okay. So the answer to that one is 2. Again, we didn't see this in our workbook this year, and I did not see this term mentioned in our program of studies, but this was on an old PAT, so it might be asked. So just something to keep in your back pocket and know about. All right, let's carry on. Okay, Frances has an equal number of nickels, dimes, and quarters. If she has $4.40 in coins then the total number of nickels that she has is what? Okay, so let's see. Always write stuff down, draw pictures, whatever you need to. So our total of money is $4.40. And it says she has an equal number of nickels, dimes, and quarters. Okay, so for example, we could have 5 nickels, 5 dimes, and 5 quarters. Okay, we don't know that we have 5, but we know it's the same amount. All right. So if I was going to get a certain amount of money, I would take if I had let's say I had 1 nickel, 1 dime, and 1 quarter. Well, how much would that be? That would be 5 cents, and then 10 cents, and then 25 cents, and we would add them all up. And here we would get 45 cents. Okay, if I had, let's move that up. If I had 2 nickels, 2 dimes, 2 quarters, I would multiply, right? So just let me write this down. This values. Okay, so I would multiply because I would have 2 times of those, right? So I'd have 10 cents. Multiply that. I would have 20 cents. And since there's 2 of those, I would have 50 cents. And we would add those all up. In this case, we would get 90 cents. Okay, but I don't know how many I have. But I do know that this number is the same, right? If I have either have 1 of everything, or maybe I have 2 of everything, maybe I have 5 of everything, but I don't know how many that is. So what do we write when we don't know something? We choose a variable. A variable is an unknown. Okay, so let's say I have got, and what did I do in this question here below? I was basically multiplying the value of my coin times the number of things. I was multiplying the value of my coin, 10 cents, times the number that I had. The value of my coin, 25 cents, times the number that I had. So I would say something like this. I've got 0.05, that's how many cents I have, times my number of nickels, sorry. Okay, so we're going to call nickels X, plus the number of dimes times my number of, this value of the dime times the number of the dimes. I don't know what the number of the dimes are, but I know it's the same as the number of nickels, so I can also call that X, plus the value of my quarters times the number of quarters. And again, they said they're all the same. So same as we had 1, if we had 1 dime, 1 quarter, 1 nickel, or 2, 2, and 2. Here I have X, X, and X. I don't know what that is, but it's the same value. Okay. And all of those have to add up to $4.40, right? We multiply those number of nickels times the value of the nickel, and then we do that for the dime and the quarter, and we add them all together, we get the total value. So I could just add those all up. Just like we can add, right? 2x plus 3x plus, I don't know, 4x. We just add the numbers. 2 plus 3, 3 plus 4, or 2 plus 3, 5, plus 4 would be 9. We'd write that as 9x. So we can do the same thing with these nickels, dimes, and quarters. So we can just add 0.5, 0.10, and 0.25. So that would be, what would that add up to? 0.05, 0.10, 0.25, and that adds up to 40 cents. So we can say that 0.05x plus 0.10x plus 0.25x equals $4.40. So if we add those all together, that adds up to 0.40x equals $4.40. And now we just have a nice little equation that we can solve. So if we divide both sides by 0.4, so we have $4.40 divided by 0.40, we get $4.40 divided by 0.40 equals 11. So x equals 11. So that's saying we have 11 nickels, 11 dimes, 11 quarters, and that will add up to our $4.40. Okay? So answer was, there it is. And that's the nice thing about multiple choice. Gives us a little feeling of confirmation when we get an answer and we see it there. So we know we did the right thing. Okay, I'm going to stop this video here and we'll carry on.